section 1.3, you learned the definition of a trig function, and from that definition, we have fundamental identities, and the first one is reciprocal identities. So this one is very simple to explain because you learned that sine theta is y over r, and cosecant theta is r over y. See, they are reciprocal to each other, so cosecant theta is simply 1 over sine theta. And similarly, secant theta, which is r over x, and cosine theta is x over r. They are reciprocal to each other, so secant theta is 1 over cosine theta. So we can reverse this, meaning cosine theta is 1 over secant theta, and sine theta in the same way is 1 over cosecant theta. So these are reciprocal identity. And similarly, tangent theta, its definition was y over x, and a cotangent theta definition was x over y. Because of that, they are reciprocal to each other, so cotangent theta is 1 over tangent theta, and similarly, tangent theta is 1 over cotangent theta. And these 6 identities, these two, and these two, and these two, 6 identities are called reciprocal identity. And now these two are called quotient identity. See, tangent theta is y over x, which can be achieved by sine theta over cosine theta, because sine theta is y over r, and cosine theta is x over r. And if you cancel 1 over r, and that is just equal to y over x. So tangent theta, y over x equals sine x over cosine theta. And we just learned it from reciprocal identity. Cotangent theta is 1 over tangent theta. So if you use reciprocal of that, meaning cosine theta over sine theta, it's going to be cotangent theta. So these two are called quotient identity. Now we are at the negative identity. So if angle theta is right here, and this one is a negative theta, and the hypotenuse is r, and hypotenuse is r. If this is a positive y, and this one will be negative y. So as you can see, sine negative theta is negative y over r, which is the same as a negative of a sine theta. And for now, when it comes to cosine negative theta, is x over r, because x, both cases, a positive sine x, whether it's quadrant 1 theta or negative theta. So because of that, cosine negative theta is cosine theta. Now tangent negative theta is y over x, negative y over x. Because of that, that's a negative of tangent theta. These 3 of them are called negative identity. Now these 3 identities are called Pythagorean identity, and possibly the most important identity. And so sine theta, square theta, so when they write it sine square theta, which means sine theta times sine theta, so it's the same as that. So which is not the same as a sine theta square. So when you mean the sine theta times sine theta, we write it sine square theta. So I hope you don't confuse the sine square theta with the sine theta square, which is not the same. So sine square theta plus cosine square theta. So cosine square theta means cosine theta times cosine theta, which we write it as a cosine theta whole thing to the square, which we write it cosine square theta. Squares is on the cosine, not after theta. So it's square is before theta. Now cosine square theta plus sine square theta is equal to 1. It's because sine theta is y over r. If you square that, that's sine square theta. Cosine theta is x over r. If you square that, and so you're getting a y square over r square, x square over r square. And now since you have a common denominator, you can add the numerator, x squared plus y square all over r square. Now you learn that r is equal to square root of x squared plus y square always. So if you square both sides, r square is equal to x squared plus y square. Since the numerator is equal to r square, so x squared plus y squared gets replaced by r squared, and r squared over r squared is equal to 1. That's why sine squared theta plus cosine squared theta is equal to 1. So we just proved this one. Now the next one is 1 plus tangent squared theta. So what we have is 1 plus tangent squared theta is 1 plus tangent theta is y over x. So y squared over x squared is a tangent squared theta. Now to get a common denominator, I'm going to replace 1 by x squared over x squared plus y squared over x squared. Now you have a common denominator x squared, so you can add the numerators x squared plus y squared. But x squared plus y squared is just r squared over x squared. Oh, that's nothing but secant squares. So 1 plus tangent squared theta equals secant squared theta. That's a second Pythagorean identity. And now 1 plus cotangent squared theta is 1 plus cotangent is x over y. So it's x squared over y squared. And to get a common denominator, I'm going to replace 1 by y squared over y squared plus x squared over y squared. Since we have a common denominator y squared, you can add the numerator x squared plus y squared. Now, of course, x squared plus y squared, we just learned that it's r squared over y squared. R over y is nothing but cosecant theta. So it's a cosecant theta squared. That's the third Pythagorean identity. Now, from the definition, sine theta is y over r, and r is always bigger than y. And because of that, this one is always proper fraction. Y can be negative or positive, and that's why sine theta is always between -1 and +1, because that's y over r is proper fractions. Similar reason, cosine theta is x over r, and r is always bigger than x, so proper fraction. So that's why cosine theta is also between -1 and 1. Now inverse this one, so cosecant theta will be either greater than 1 or less than -1. So cosecant theta will be either greater than 1 or less than -1. And which write it as a cosecant theta reciprocally is greater than 1, meaning distance from 0 is always bigger than 1, further away than 1 or -1 from 0. So we write that as an absolute value of cosecant theta is greater than 1. Similar reason, secant theta is either greater than 1 or secant theta is less than -1. We write it, so distance from 0 is greater than 1 or less than -1. And so we write it simply that as a secant, absolute value of secant theta is greater than 1. So that gives you the range of cosecant and secant. And range of sine and cosine is between -1 and 1. Now tangent theta is y over x. So y can grow really big while x can remain as small. Because of that, there is no limit on the number of y over x. So that's why tangent and cotangent theta is between -infinity to +infinity. Now, I combined all the identity. Now, how do I use this full identity, which we'll call it a fundamental identities. So when they mention fundamental identities, it's a reciprocal, quotient, and Pythagorean identity and negative identity. Now let's look at one example. How do I use this identity? Now it says cosine theta is given to you as a 4 over 5 and tangent theta is given to you as a negative 3 over 4. Now that comes down to you have to determine theta is in which quadrant. Now think about that. By the definition of sine and cosine and tangent, and here in quadrant 1, x and y are both positive. So sine and cosine and tangent, all of this function will be positive on quadrant 1. On the other hand, in a second quadrant, sine theta is y over r, and second quadrant y is positive. So y over r will remain positive, but cosine theta is x over r, and r is positive, x is negative here for second quadrant. Because of that, cosine will be negative. And tangent theta is y over x, and y and x are opposite signs, so tangent will be negative. So as you can see here, all function is positive. In second quadrant 2, sine is positive and all the others will be negative. If the sine is positive, you can assume that cosecant is also positive implied. If cosine and tangent are negative, then secant and cotangents are also negative in quadrant 2. Now, because of that, and then quadrant 3, y and x are both negative in quadrant 3. So that means the sine and cosine will be negative. And what will remain positive will be tangent because y and x are same sign. So negative divided by negative will be tangent will be positive. And that means the other will be negative. Now here cosine theta, in quadrant 4, x is positive and y is negative, and r is always positive. Because of that, cosine theta will be positive and all the others will be negative. So this one means a sine theta and a tangent theta, and the reciprocals have the same sign as cosine and sine and tangent. So if cosine is positive, secant is positive. If sine is negative, then cosecant is negative. Tangent is negative, that means cotangent is negative, so it's implied. So we call this for quadrant 1, all function is positive. In quadrant 2, sine is positive. In quadrant 3, tangent is positive. In quadrant 4, cosine is positive. So we call that all student takes calculus. And so all function positive, sine positive, tangent positive, cosine positive. So if you remember this one, you will see which quadrant will be, which trigger function is positive in which quadrant. Now let's look at this example right here. It says cosine is positive, yet tangent is negative. That means it cannot be quadrant 1. Now, in which quadrant cosine is positive and tangent is negative? It has to be quadrant 4. So we know that theta is in quadrant 4. In such a case, so assume, so since cosine theta is 4 over 5, and that's a positive, and tangent is negative 3 over 4, negative. So because of that, theta is in quadrant 4. In quadrant 4, you know sine is negative. But now this question specially state that you need to use a fundamental identity. And so I cannot use a definition. I have to use identity because the question instructed you to use identity. So then I have to think about which identity give you a relationship between sine and cosine. Especially, I could use tangent theta is equal to sine theta over cosine theta. Since cosine and tangent is given to you, tangent theta is sine theta over cosine theta. And cosine theta, tangent theta is negative 3 over 4, and cosine theta is 4 over 5. And so sine theta, and this implies sine theta is equal to, I multiply cosine theta both sides, is a cosine theta times tangent theta. So I can simply multiply cosine theta 4 over 5 multiplied by negative 3 over 4, which is tangent theta. And when you're multiplying fractions, you can cancel numerator and denominator same factor. And you can see that what you have in the numerator, once you cancel 4 over 4 as 1, you have negative 3 over 5 as your sine theta. So I just used which identity? I used the quotient identity. So here I used the quotient identity. So if the question asks you to use a fundamental identity, you need to identify which identity you use. Now, find all the four other trig functions. So I found the sine theta using quotient identity. Now it's a matter of using reciprocal identity. So sine theta is negative 3 over 5, which means cosecant theta is the reciprocal of that. So invert the fraction, negative 5 over 3. And secant theta is 1 over cosine theta, meaning invert this fraction, so 5 over 4. And cotangent theta is 1 over tangent theta, so invert this one, 1 over tangent theta, so inverting the fraction of negative 3 over 4, so negative 4 over 3. So now we found all other trigger functions using identities. So these two are reciprocal identity, 1 over sine theta and 1 over cosine theta. So I use the reciprocal identity. And quotient identity. Now let's look at another example. Previous example had a 2 trigger function given to you. Now again, I want you to pay attention. It says use the fundamental identity, which means all the identity I just mentioned it, reciprocal, quotient, and Pythagorean identity. And this time, instead of giving 2 trigger functions, it's giving only 1 function. And we know that cosine is negative, tangent is negative. You have to figure out which quadrant theta should be in. Now, which quadrant, since cosine is negative and tangent is negative, it cannot be quadrant 1. So you have to understand it has to be the quadrant where cosine and tangent are both negative. Cosine and tangent are both negative. That means it's quadrant 2. In quadrant 2, sine is positive. So you can see sine is positive. Now, since cosine is given to you and there is no other trigger functions value is given to you, the only identity that has sine and cosine in it is Pythagorean identity. So we have a Pythagorean identity, sine square theta plus cosine square theta equals 1. So that's an important section, important identity, Pythagorean identity. And sine square theta plus cosine square theta is equal to 1. That means the sine square theta, by subtracting negative cosine square theta to the other side, 1 minus cosine square theta, which means sine theta is plus minus square root of 1 minus cosine square theta. Now, plus or minus, but since sine theta has to be positive in quadrant 2, we determine that. So since cosine and tangent are both negative, we determine that theta should be in quadrant 2 because that's where the cosine and tangent are both negative in quadrant 2. In quadrant 2, sine is positive. Don't forget, sine theta should be positive in quadrant 2. So I'm dropping negative sign. So what we have is sine theta should be equal to positive 1 minus square root of positive square root of 1 minus cosine square theta. And so now I'm substituting cosine theta by given value, negative 5 over 13, but you're squaring this. And so when you square the negative, it will be positive, so it will be 25. And so you need to square first. 25, 13 squared is 169. And so to do the fraction, so don't forget negative squared is a positive and there is a subtraction sign. So that one remains as it is. And now square root of, now to do the fraction subtraction, I need to change it one with the common denominator, 169 over 169 minus 25 over 169. They're all inside of the square root. 169 minus 25 is 144 over 169. So it becomes square root 144 over square root of 169. So it's 12 over 13. And that's my sine theta as a positive number. Now, once we have a sine and cosine theta, so I use the Pythagorean identity. Now, tangent theta, so here, tangent theta, I'm using a quotient identity. Quotient identity says tangent theta is a sine theta over cosine theta. Sine theta, we just found it 12 over 13. And then cosine theta was given to you as a negative 5 over 13. Positive divided by negative answer should be negative. Now you can cancel 1 over 13, 1 over 13, you cancel it. What's left is 12 over 5, and that's tangent theta. And after that, I use reciprocal identity. So cosecant theta is 1 over sine theta. So that means invert this 12 over 13, which is 13 over 12. Now secant theta is 1 over cosine theta. So inverting negative 5 over 13. Cosine theta is negative 5 over 13. So invert that one will be negative 13 over 5. And cotangent theta is 1 over tangent theta. So inverting the tangent theta. So tangent theta, we found it to be negative 12 over 5. So it's inverting negative 5 over 12. So we've used 3 different identities. Start with the Pythagorean identity, quotient identity, and reciprocal identity.